Ladies and gentlemen, here we go. Section 9, the last section of Chapter 10. Congratulations, we're almost there. We're almost through this big old chapter. But the question is going to be, how do you find the arc length of a circle? Notice it's not saying what is the arc measure. No. We're talking length now. So let's dive into this and let's go back to what we know from elementary school with something called circumference. So we all remember this. I put this into your notes somewhere, but you got this circle. You got circle A. You see the radius length here from A to G is 6.4 centimeters. The circumference of a circle is nothing more than this equation. Circumference equals pi times diameter, or 2 pi r. But you remember, I taught you this. It's cherry pie delight, so I like to make it pi times d, so we don't get confused of what 2 pi r is or pi r squared. So all this being said, what I want you to remember really is the basics of what circumference is. Circumference, guys, is nothing more than the distance around an actual circle. So if you start here, well, we'll start here at G. If you start here at G, there you are, look at you. Oh, yeah, there you are. Cool. And you start walking. You start bobbing. You start walking. You keep on walking. You keep on walking. Well, maybe, hopefully not in that path. But if you walk the whole way around, that's ugly. If you walk the whole way around this particular circle, and you start at G and you go the whole way around and end at G, according to what this is telling me, the circumference of the circle is somewhere around approximately 40 centimeters. Now, it's a decimal, again, because we're talking about taking something times pi. So this is an approximation. It should say approximation up there of 40 centimeters. So you would walk 40 centimeters the whole way around this shape. That is a piece of cake. Well, not really a piece of cake, because I'm going to show you this. What if we transpose, yummy, a pizza on top of this? So what you've just found, guys, is this. You found that the length of crust, if you will, if the diameter of this pizza is 6.4 centimeters, I'm sorry, if the radius is 6.4 centimeters, then the diameter is 12.8 centimeters, yes. So you plug that in, great, all that stuff is good. But that means the distance around this entire pizza would be 40 centimeters. So if I cut right here where G is on the pizza, and I cut around and just cut off the actual, well, if I cut off the crust of this pizza and I laid it out straight across, what it's saying is it would be exactly 40-ish, somewhere approximately 40 centimeters across. That's the distance and length of the circumference. Why am I taking 2.5 minutes to show you what in the world circumference is? Because remember, the actual question here that we're talking about in this video is, how do you find arc length? So back to this. I'm not asking you what the whole entire circumference is. This video and this lesson, this section is saying, what if I just took a part of? What if I just took a fraction of? What if I just took a piece of? What if I did this? Sorry. What if I just had like a piece of pizza? Not the whole entire pie. I just had the whole, just one little piece of pizza. What's the distance from there to there? Now we're talking a little bit of a different ballgame. We're not talking entire part of a circle. I'm sorry. We're not talking about the entire circle. What's a good drawing I just did right there. So now we're looking at how long or what the length of this piece to this piece actually is. That's the overall thing. It looks like headphones that the thing has on. Yeah, rock on, piece of pizza. Woohoo! Yeah, rock on, I am jamming. What up, dudes? Okay, anyways. So that is the overall idea here, what's going to happen in this little video, in this lesson. So what is the length of this arc length of the overall entire circle if I overlaid a circle on top of it? So there's the entire circle, but I'm only looking for that piece right up there. Got me? Game on, let's do it. So let me break it down for you in a simple way. Back to this picture with this 4 different kinds of little sections of pizza here. If I just kind of do this, let's say we section off this entire pizza into 4 exact sections, which you can see it kind of is. Pepperoni, and I guess that's onion. I think that's ham and mushroom. This is big old tomatoes and little leaves, and these are big old leaves, and I don't know what they are. Maybe, I have no idea. Onions, garlic, I don't know what they are. Doesn't matter. But here's the deal. If you know the overall circumference, the entire distance around this circle is 40. And now, remember, it's approximately 40, but let's say it's 40. And I wanted to know just this piece from here around to G. How would you figure it out? Well, you know this. I just sectioned this entire pizza off into fourths. So what you're doing is you could really take 1/4 of the overall circumference of the circle, and you would all know this. This has to be 10. This piece over here has to be 10, a length of 10, approximately 10 centimeters. This one right here is 10 centimeters, and this one right here is 10 centimeters. Why is that the case? Because, again, the whole thing's 40, and I just take it in fourths. It's as simple as that. So I'm taking 1/4 of the overall circumference to get this little piece right there. Got me? Cool. What if I did this, though? What if I take the whole entire pie and cut it into 6? Ooh. So if I take this thing and cut it into 6 like this, well, now, what if I ask you, what is this length? Or what is the length from J over here to I? Well, how could you figure that out? Well, again, I just cut it into sixths, like I said. So I could take 1/6 of the overall distance around the entire circle with a pizza. So I would take 1/6 of 40, and that would give you each of these little individual arc lengths right there. Okay? What is that, by the way? Let's do it. 1/6 of 40. So let me pull over my insert here. So 1/6, so 1 divided by 6 equals that, times 40, bam. So it gives you approximately 6.7 inches, as you see right there. So each of these little guys in here would be somewhere around 0.6 repeating, or 6.7. That's cool. Now what if I ask you this? What's the distance from H? Now notice I'm saying distance, not measure. What's the distance from H the whole way around here to K? Well, that would be just 6.6 times 2. Because you know all these are kind of sectioned off into 6 little pieces. Okay? All that's great. All that is wonderful. What if I did this, actually? What if I took this piece of pizza? Now, I couldn't do this. I just kind of did this. Yeah, I know it's a weak picture. I got you. But look, what if I took this whole entire piece of pizza, or the whole entire pizza, the pie, and I sectioned it off into 8 sections? Well, that would be 1/8 of the circle. So here's the deal. How do you find the arc length given a picture? Well, let's go back to the original one we did. Remember we had this one right here where it was sectioned off into fourths? You guys know this. If it's sectioned off into fourths, that right there is a right angle, which means we're talking about 90 degrees for the central angle, which, ooh, by the way, means I'm looking at 90 degrees measure-wise for the measure of the arc. But if you remember, go back to the video, what we did, and you know this, we took 1/4 of the overall circumference of the circle to find the length of that arc right there. Wow, that was a lot of words. But wait, I want you to think about this. Where does 1/4 actually come from? So where does this 1/4 really come from? Well, it's actually 90 degrees that I know that the arc measure is over the total 360 that the circle could be. And if I reduce 90 over 360, ladies and gentlemen, bam, you get 1/4. So what am I showing you this for? Because in order for you to find the arc length of a circle, you can always find the total circumference, you betcha, and then figure out, you know, what I can divide by 4s, 6s, 8s, or whatever. Or you could use Theorem 98 and just plug in the numbers and rock and roll. And here's what Theorem 98 says. It says this: if you have a circle like such and you're finding the length of the arc, all you have to do is you have to find the measure of the arc that you're looking for. Now again, length of the arc and measure of the arc are two different things. Measure of the arc is the amount of degrees that it is. And oh, by the way, remember, the measure of degrees the arc is exactly the same as the measure of the central angle. So, once you know the central angle, you also know the arc. If you know the arc, you know the central angle. But all you need to do is find the measure of the arc and divide that by 360. What that's going to tell you is the fraction of the overall circumference that you want. Do I want 1/4 of the overall circumference? Do I want 1/8? Do I want 2/3? Do I want 3/4? Depends completely on the question. But you put 360 on the bottom because that's the total amount of degrees that a circle could be. And then you figure out the arc length, the measure of the arc. And that tells you the fraction, the overall fraction. Then notice over here to the right, what you're looking at is just nothing more than the overall simple circumference of the circle, the total circumference. So it's a fraction, whether it be 1/4 or 1/6 or 1/8 or 1/9 or 1/12 or whatever of the overall circumference. So there is your theorem. Oh, by the way, there is another way that you can write this. This is how it's written in your book. But another way to think about it would be, as I just said, hey, you don't have to go that simple little step and say, well, let me find the arc measure. No, because if you know the central angle, like I said, you can put the measure of the central angle right here on top. It's still going to tell you the fraction of the circle that you're dealing with. That will tell you the arc length. So it is, guys, exactly that simple. Like I said before, I don't know, let's make one up real quick. Let's say that the radius of this circle is 8, completely making it up on the spot. And let's say that the measure of this angle right here is 100 degrees. Well, if I ask you to find the length, not the measure, the length of the arc from A around here to B, what would it be? So what's the length of that arc? Pause the video right now. Do it. And then see what you get for an answer. Bam. Did you get the answer? 13.96. How'd you get that, Motter? Well, 100 is my central angle, which means it's the same as the arc. So I put 100 right here on top, right here for the central angle. 360 never changes. That's the circle's measure angle degrees, whatever. Measure of degrees around the circle. And I take that times pi times 16. Where did the 16 come from? Don't forget, we're talking pi times diameter. And if 8's my radius, times 2 gives me the diameter. So you take 100 over 360, put that in your calculator, take it times pi, take it times 16, you get 13.96. That, ladies and gentlemen, is your answer. Congratulations. We're going to master this, finding the length of the measure of an arc in any circle. I don't care if it's a piece of pizza, if it's a pie, if it's a, I have no idea. Doesn't matter, but we're going to practice it and master it. You guys are awesome. We'll see you in class. Later.